Unit 5, Lesson 12, Reasoning about Exponential Graphs, Part 1. Our learning target says, let's study and compare equations and graphs of exponential functions. We're going to be working from page 809, so please go there with me. Activity 12.1, Spending Gift Money. Jada received a gift of $180. In the first week, she spent a third of the gift money. She continues spending a third of what is left each week thereafter. Which equation best represents the amount of gift money G in dollars she has after T weeks? Be prepared to explain your reasoning. So what I notice here is that our initial value, our initial amount is $180. And if she spends a third of the gift money every week, how much is remaining? Okay, so if she spends a third, what remains? That should be 2/3. Okay. Now, just by the way that it's worded, where it says she's spending a third every week, that leads me to believe that this is an exponential function. So if we look at our options here, number 1 is actually a linear function. So we can cross that one out. And we know that 180 is our initial amount. So we can go ahead and cross out number 3 because 180 is the growth factor there instead of the initial value. So here we've kind of like whittled this down to options 2 or 4, and they both have 180 in the initial amount place, so like where A is, and then we have 1/3 for the growth factor or 2/3 for the growth factor. Well, if we know that she spends 1/3, what remains is 2/3, and we know that what remains is always what goes into the equation. So here, what remains is always going to go in the equation, and that's what we have here. So 4 is going to be our correct equation. All right, 12.2 is equations and their graphs. This is going to be found on page 810 and 811. Number 1 says each of the following functions, f, g, h, and j, represent the amount of money in a bank account in dollars as a function of time x in years. They are each written in the form m of x equals a times b to the x power. Okay, so f of x is 50 times 2 to the x. G of x is 50 times 3 to the x. H of x equals 50 times 3/2 to the x. And j of x equals 50 times 0.5 to the x. A says, use graphing technology to graph each function on the same coordinate plane. And B, explain how changing the value of B changes the graph. Okay, well, one thing I notice here is that all 4 graphs have the same initial value at 50. Okay, so we know that that's going to be the y-intercept for each of these graphs. Now, what differs is that growth factor or decay factor. So here, because we have 2 in place for f, for the decay factor, 2 means that this graph is going to be doubling. So let's just make these notes real quick. This is going to be doubling, which means you're going to be multiplying by 2 each time. So obviously the first term is 50. If we double 50, we get 100. If we double 100, we get 200, and so on and so forth. For g of x, because we have 3 in place of the growth factor, it's going to be tripling each time. So we're going to be multiplying by 3. So if the first term is 50, we're going to multiply 50 by 3. We then get 150. Multiply 150 by 3, we get 450, and so on and so forth. Okay. For h, our growth factor is 3/2, and 3/2 is 1.5. So we're just going to multiply by 1.5 each time. And then for j, because 0.5 is less than 1, that's actually going to be a decay graph. So here we have a graph that's going to be decaying. Okay, so let's just make a note of that. All right, so we don't technically need to use graphing technology. We should know how to graph this already. And we'll just put 50 on the graph. Okay, so let's get rid of this. All right, let's draw f of f in red. So we know it's going to start at 50, and it's going to increase, or it's going to double each time. So let's just go like this. Okay, that's f. All right, then let's do g of x. So g of x is going to triple. So it's actually going to be growing faster than f. So we're going to start at 50, and it's going to be a little bit steeper than f. H, oops. H we'll do in green. And so this is going to be increasing by 1.5. So it's going to be a little less steep than doubling. So we're going to draw it out here like this. And then for the last one, we have j of x, and we're going to draw that in purple. And that's going to be decaying by a half. It's going to look kind of like this. All right. Now, those aren't like 100% accurate, but it gives us an idea of what's happening. All right, so that's A. Let's go to B. Explain how changing the value of B changes the graph. Okay, well, hopefully you've realized that when B is greater than 1, that shows exponential growth. And when B is between 0 and 1, meaning it's like a fraction less than 1, that's going to show exponential decay. Another thing that we should notice or make note of is when we're looking at these values that represent exponential growth, 2, 3, and then 1.5 or 3 halves, the one with the larger growth factor is going to be growing more quickly. All right, and then feel free to add any other additional notes that you want to add there. All right, number 2, it says here are the equations defining functions p, q, and r. They are also written in the form m of x equals a times b to the x. Okay, so here we have p of x equals 10 times 4 to the x, q of x equals 40 times 4 to the x, and r of x equals 100 times 4 to the x. So one thing that you should notice right off the bat is that the growth factors are the same. They're all quadrupling. Okay, so this is all exponential growth. All right, what differs though is that initial value here, 10, 40, and 100. Okay, so A says use graphic technology to graph each function and check your prediction. Explain how changing the value of A changes the graph. Okay, let's use different colors here. So we'll use red, blue, and purple. Okay, let's make the graph. And you guys have a lot more room than I do, so please make use of the space. Okay, let's start with red. P of x is going to start at 10, and it's going to grow pretty quickly. And then the blue graph is going to start at 40, and it's going to grow at the same rate. And then R is going to start up here at 100, and it's going to grow the same amount. Oops, I forgot to label my graphs. All right, so explain how changing the value of A changes the graph. Well, hopefully you notice that the initial value, or A, represents the y-intercept. So it's always going to be 0, comma A. So here we have 0, 10. Here we have 0, 40, and then 0, 100. Okay. Another thing that you need to note is that A shifts the graph up or down depending on the value. kind of gives us a vertical shift. And let's notate A as the initial value. Remember, our equation is always A times B to the X. And feel free to write down any other patterns that you see. All right, let's move on to 12.3, graphs representing exponential decay. This is going to be on page 812 to 813. So this is one of my favorite activities, mostly because it's matching and I love matching. Number 1 says, match each equation with a graph. Be prepared to explain your reasoning. So if we look at the graph, the lines that are there are represented by letters A, B, C, and D. And we see that D is actually decaying a lot more than C, B, and A. And they all start at 200. So if we look over at the equations M, N, P, and Q, they all start at 200, okay, because that's the initial value. And then they give us values that are less than 1, so between 0 and 1 in the parentheses, where our decay factor would be. So one thing that we need to remind ourselves, because this can get a little tricky, is that the number inside the parentheses is actually what remains, okay? So if I were to look at the first one, m of x equals 200 times 1/4 to the x power, if 1/4 is remaining, how much is decaying? Well, it's going to be the other part of the whole, right? So 1 minus 1/4 gives me 3/4. So this is actually decaying by 3/4. Let's make it so you can see that 3 better. All right, so n of x equals 200 times 1/2 x. So if 1/2 is remaining, it's going to decay by 1/2. P of x, if 3/4 is remaining, that means that it's decaying by 1/4. And then Q of x, 200 times 7/8 to the x power, 7/8 is remaining. So it's going to decay by 1/8. Now, one thing you should know, if you don't know what these numbers are, 3/4 is 0.75, 1/2 is 0.50, 1/4 is 0.25, and 1/8, let's see, 1/8 would be half of 2/4, 0.125, so half of 0.25 is 0.125. Perfect. All right, so clearly we see that 0.75 is the largest, and so we're going to match M with the graph that's going to decay the most. So let me just set this up. So M decays the fastest, so that's actually going to be graph D. And then N is going to decay the next fastest, so that's going to be C. P decays the next fastest, so that's going to be B. And then Q has actually like the smallest decay factor, so that's going to be A. And there's a lot of problems on your homework that will help practice this. Let's look at number 2. Functions f and g are defined by these two functions. F, which is 1,000 times 1/10 to the x power, and g of x, which is 1,000 times 9/10 to the x power. Which function is decaying more quickly? Explain your reasoning. And then B says, use graphing technology to verify your responses. Okay, so for f of x, if we look at f of x, if 1/10 is what's remaining, because that's the number that's inside the parentheses, that means it's going to decay by 9/10. And then g of x, if 9/10 is in the equation, it's actually going to decay by 1/10. So which one is actually decaying more quickly? It's the one that decays with the largest number. So that would be 9/10. So that's function f. So I'm going to say function f decays more quickly than function g, since 9/10 is greater than 1/10. Okay, and if we were to graph this, They both start at 1,000 up here. Okay, because f of x decays 9/10, it would go down like really close to the x-axis like that. And then the orange will be more similar to A back here up on the very top. It'll be a little bit flatter. It's not going to decay as quickly. So let's make it a little bit of a curve like that. Okay. All right, the lesson 12 summary is on page 814. And I'm going to have you highlight the first sentence. It says, an exponential function can give us information about a graph that represents it. So again, the biggest thing that you should recognize is the y-intercept, because the y-intercept gives you the initial value. But then also when looking at the graph, let's look at this paragraph. It says all three graphs start at 5,000, but the graph of R grows more slowly than the graph of Q, while the graph P grows more quickly. So this makes sense because the population that doubles every hour is growing more quickly than one that increases by a factor of 1.5 each hour, and both grow more quickly than a population that increases by a factor of 1.2. Okay. So big takeaway is to know what do A and B in the exponential graph or in the exponential equation represent. Thanks for joining me today in learning lesson 12. If you have questions, please reach out to your teacher.